Hello, good morning. So this is Reshma going to discuss an very important topic in design and analysis of algorithms, that is a subset problem using backtracking. So now we'll see the problem statement. What is subset problem is. So now in subset problem they have given a set of n numbers and a sum of some positive integers d is given. Now from the given set we need to find all possible subsets such that sum of elements of those subset must be equal to the given sum. Now for example here in example 1 I have a set S which contains the elements 1, 2, 5, 6, 8 and the required sum D is 9. Now here for this problem we may have a solution where there may not be any solution or we can get more than one solution also. So now here I got two solutions S1 and S2. In S1 we have selected the elements 1, 2, 6 as one subset because the sum of 1 plus 2 plus 6 is 9, and in set 2 I have selected 1, 8 because again 1 plus 8 is 9. So these are the two possible subsets from the given set is whose sum is equal to 9. In the same way, if I take some second example, here the set S contains again some 4 elements, required sum is 15. Here I got only one subset S1 3, 5, 9 which sum as 15. Now if I take one more example with the same set, S contains 3, 5, 6, 7 and the required sum is 100. But from the given set, it is not possible to form any subset whose sum is equal to 100. So we can say here this subset problem has no solution. So now we will apply backtracking technique to find all possible subsets for the given sum from the given set. For that we need to construct a state space tree. The state space tree can be constructed by using some rules. The first rule is the root of the tree should represent the starting point. So before selecting any element from the given set, first I need to write a root as the starting point. After the root, we have to go for the first element and either I can include that element or I can exclude. If I include that, I have to represent as left child, and if we are excluding that we should represent as right child. So left of S1 again represent the inclusion of S2, right of S1 represent exclusion from S2. In the same way in the next level left of S2 will be inclusion of S3, right of S2 will become exclusion of S3. So in the same way if you continue we will complete inclusion and exclusion of all the elements from the given set and the state space tree will be ready. When the state space tree is constructed completely, then to find the solution we need to find a path from root to a node on the some particular ith level of the tree which indicates some solution for the given subset. So now to clearly understand this state space tree to find the subset, so here we will consider an example of set S contains 4 elements and to find the sum as 15. As we know the state space tree will start with a root node as the starting point. So before selecting any elements, so the root contains 0. So after this, so next we have to go for the first number 3, include that number 3. If I include 3 here, 0 plus 3 will become 3. So then next number is 5, include 5. If I include 5, 3 plus 5 is 8. So now here 8 is less than required some 15. So you can continue by including the next number. So the next number is 6. If I include 6, 6 plus 8 becomes 14. Again 14 is less than 15. So I may try to include the next number. The next number is 7. So now if I include the next number 7, so 14 plus 7 becomes 21, which is greater than our required sum 15. So now here what we can see is if I follow this path from root to this particular node, it is not possible to get the solution. So this is the bad choice which we have done by including all the numbers. So now we have to apply the backtracking technique, and we have to backtrack by excluding the number which we have included at the leaf. The last number which we have included is 6. So include or exclude 6. If I exclude the 6, now our sum go back from 14 to 8. 8 is less than 15. So now try to include the next number. So the next number is 7. So include 7. By including 7, now my sum become 8 plus 7 as 15, which is equal to our required sum. So now here this path starting from root till the node 15 to till this level, I got one solution. So then in backtracking technique we may get more than one solution also. So now what I will do is, using inclusion and exclusion of the given numbers using backtracking, I will try to find if there is any other possible solution. So now after this solution, now again I will exclude 7. If I exclude 7, this is 8. Again backtrack with by removing 6. Then I will come back to here. Up to this point, below this all possibilities are done, including 5, 6 with 6 without 6, with 7 without 7. So now here only I have done only up to with 5. So then for 3, now I will exclude 5. If I exclude 5, sum 3 remains 3. Next step is inclusion of 6, exclusion of 6. If I include 6, 9 plus 7 is greater than 15. If I exclude 6, 3 plus 7, again it is less than 15. So if I include the next number or exclude the next number, then also I am not getting the solution here. Again this is the bad choice till I came here. So what I will do, again I will backtrack from 3 without 7, without excluding 7, excluding 6, excluding that is without 5. Then I'll come to here with 3. So in the left tree we have only with 3. So now by excluding 3, I will try to find the subset if it is available. So now excluding 3, without 3 the sum remains 0. Now again I have to go for next number 5 with 5 and without 5. So if it is with 5, 0 plus 5 is 5. With the 5, again I have to go for the next number 6. With 6, with 6 is become 11. 11 is again less than 15. So then I have to go for with next number 7. With 7, so 6 plus 11 plus 7, it exceeds 15. So the bad choice. So again I have to exclude 7, then exclude 6. If I exclude 6, the sum 5 will be carried here. Then 5 plus 7, again it is less than 15. Again there is no possible solution, so backtrack. Now again I'll continue with here with 5 is done. Now without 5, so previous sum 0 will be carried here. So without 3, without 5, the next number is 6. With 6 and without 6 I have to do. With 6, sum will be 6. Then next number 7, 6 plus 7 is 13, which is less than 15. So again this is not equal to our required sum. Again if I go for exclusion, here also 14 plus 7, which is greater than 15, this is not equal to 15. So now here the state space tree is constructed fully. So all nodes or all the values are considered in each level, that is here there are 4 elements in the set. So the state space tree will contains 4 levels. In the first level we have to check for inclusion and exclusion of first number 3. In the second level we have to consider inclusion and exclusion of the second number, this 5. See here second level, inclusion of 5, exclusion of 5. Again in third level we have to go for number 6 with without 6, with 6 without 6, with 6 without 6, that is inclusion and exclusion of the 6. Then in the last number is here 7. So inclusion of 7 or exclusion of 7 will come in the last level. So that is for node 16 either includes 7 or excludes 7. Again here include 7, exclude 7. For node 9 include 7, exclude 7. So even though I have not drawn here left and right child, because directly by seeing 3 plus 7 greater than 15, 11 plus 7 greater than 15, we can see that it is not possible to get the solution. Instead of writing left and right, here itself I have given some statements. So but here if we want, we can write left and right child for each and every node also. So that is here all nodes are represented in each level. 4 no level values in the given set, 4 levels we have to include in our state space tree, and at the end if the sum is equal to 15, that is our possible solution, otherwise there is no solution. So now after constructing this complete tree, we can conclude that there is one possible solution, and the solution is, you can see the tree here starting from root. Red color I have given 0 to 3, 3 to 8, 8 to 8, 8 to 15, that is with 3, with 5, without 6, with 3 means 3 comma 5 comma 7. 3 comma 5 comma 7 equal to 15 is our solution. So this is the way to find possible subsets of sum equal to the given sum D from the for the given problem statement of set yes. So if you have any doubts regarding subset problem using backtracking, please feel free to post your questions through my link. Thank you.